Hello, everyone. Welcome to video 2.8. In this lesson, we're going to be talking about representing measurements and specifically talking about the concept of significant figures. We're going to have two lesson goals today. We're going to determine the correct number of significant figures in recorded measurements and also learn how to round measurements to the correct number of significant figures as we calculate with them. So I am on page 137. And here we are talking about how using significant figures is going to allow us to maintain a correct level of precision when we're working with measurements. Sometimes significant figures is also called significant digits, and they are the number of digits that are used to express a measure to the appropriate degree of accuracy. There are a few rules that you need to keep in mind when working with significant figures, or sig figs as it sometimes goes by as a abbreviation. First of all, any non-zero digits, so 1 through 9, are always significant. So in this example here, 2.14 or 2 and 14 hundredths, there are three significant figures, 2, 1, and 4. The second rule is that in whole numbers, zeros are significant if they fall between non-zero digits. So here is a non-decimal number, 5,078. There are four significant digits, every single one of these, because the zero is significant since it falls between other significant figures in a whole number. The third rule is that in decimal numbers that are greater than or equal to 1, every digit is significant. And so in 7.60, we have three significant figures, 7, 6, and 0. And in decimal numbers less than 1, the first non-zero digit you come to and every digit to the right of that are significant. So here we have three places to the right of the decimal point, but only the 2 and the 9 are significant. So in example 1, we're asked to determine the number of significant figures in each one of these measurements. Let's take them one at a time. So the first one is 0.0320. This is a decimal number that is less than 1. And the first non-zero digit that we come to is 3. There are two digits to the right of 3, which are 2 and 0. So this measurement has three significant figures. The second measurement is 107,000 centimeters. Because this is a whole number, zeros are significant if they fall between non-zero digits. So our non-zero digits are 1 and 7, and there is 1 0 that falls in that range. So this measurement also has three significant figures, the 1, the 0, and the 7. Take a quick pause on this video and see if you can determine the number of sig figs in each of the measurements in this check here on page 138. We can also use sig figs to find measurements using tools. And so here we are with an example of a measurement, and we're asked to find the possible range for the length of the segment using the correct number of significant figures. So if we look at this ruler, the length of the segment is approximately 1.5 inches. This measurement is given to the nearest 1/4 inch. That's the unit of measurement that it's broken down to in the smallest way. So the possible range of this measurement is within 1/2 of that 1/4 or 1/8 of an inch of the measured length. So the exact measurement is between 1 and 1/8 less than 1.5, which would be 1 and 4/8. So 1 and 3/8 and 1 and 5/8, which in decimals is 1.375 and 1.625. And due to the precision of this ruler, following the sig fig rule that decimal numbers greater than 1 every single digit is significant. And so we have four significant figures here. Take a pause on the video and see if you can find the possible range for the length of the segment here on this example. Next, we're going to learn a little bit about what happens when we calculate with significant figures. And so if we're calculating with sig figs, the accuracy of the result is limited by the least accurate measurement. So in addition and subtraction, when we are calculating, it cannot have more digits to the right of the decimal point than either of the original numbers. And in multiplication and division, the number of significant figures in the product or quotient is going to be determined by the original number that has the fewest number of figures. It's also important to talk about what qualifies as a number that needs to have significant figures considered. So, first of all, numbers that are not measured are not considered when determining significant figures. So, we have an example here that if we have five cereal boxes that weigh 14 ounces each, the significant figures used in the calculation would only be determined from the actual measurement of 14 ounces, not the quantity. So if we can think of it as discrete numbers or counted values, those ones are not considered in sig fig calculations. The second exception that we have is conversion factors. So if we're taking a conversion 12 inches equals a foot, that conversion significant figures would be determined by whichever the original measurement is that's being converted. So if we take these two different sig fig rules to apply to the examples we see here on page 139, then the first part, part A, says we're going to take volume initial sample and remove some out of it. Hopefully you can understand that that's a subtraction operation. And for part B, we have an area of a rectangle that we are calculating, and we know that that formula is length times width, so we want to follow the multiplication sig fig rules. First off, our subtraction example, 837.24 has two digits after the decimal, and 276.516 has three digits. So the result should have, remember we go with the lowest amount of sig figs after the decimal. So that's two digits after the decimal. So if we find the difference, 837.24 minus what we're taking out, 276.516, on our calculators, we get 560.724, but we need to round to two digits. So again, remember our rounding rules. We're going to look at the digit to the right of where we want to stop, and that 4 is going to not move us up to the next hundredth. So we're just at 560.72 milliliters. In our area example, which is multiplication, we have the dimensions 4¼ inch and 2½ inch written as decimals. When we multiply them, we know that the smallest number of sig figs is 2, and we get 10.625. So using significant figures, we need to consider that the area is going to be rounded to the nearest whole unit. So that would be 11 square inches. And that's again taking our cue from the 10th place of 6, which is going to bump us up to the next whole value of the single unit digit. Take a pause in the video here for the examples on page 139, the check example. See if first of all you can determine what operation is suggested, and then round to the correct number of sig figs. Here on page 140, we have an example of sig figs in a calculation of a real world object. So we have a flower garden, and we have the world's second largest flower garden in Keukenhof Park in Lies, which is in the Netherlands, which covers 79 acres and contains 7 million flower bulbs. About 30 gardeners work together each year to design those flower formations. We want to know how many bulbs they use in each square yard of the garden, and we want to round this to the correct number of significant figures. As we look at this description, hopefully you are agreeing with me that 79 is our measured value. So we're going to divide the total bulbs, which is 7 million, by the 79 acres. And we're going to convert that with our conversion factor here of 1 acre being 4,840 square yards. There is no need to memorize these conversion factors. We will make sure that we provide them for you in the description of the problem. So when we go ahead and do that division, we get 18.307 and some other digits there, but let's go ahead and talk about sig figs for a second. So again, taking that number that we just came up with, that came from our calculator division, we're doing sig figs on this. So the number of bulbs is a quantity, a counted number, not a measurement like the 79. And so we're going to determine our sig figs from the given measurement, which is 79. So we know that 79 has two sig figs, and so the final product should also have two sig figs. Therefore, if we look at the tenths place and discuss what that does to the units digit, that means that they use 18 bulbs in each square yard of the garden. Take a pause in this video and take a look at the check for example 4 on page 140 and see what you can come up with this calculation here for snow removal. Finally, we're going to use some tools to calculate measurements. In this particular example, we have the radius of a circle has the measurement shown. If we look at that measurement, we're going to say that that is 7, and then each of the units that the centimeter is broken down to is millimeters. So we would say 7.6 centimeters. And like we said, this is to the nearest tenth of a centimeter or millimeter. So the approximate error is half of that, zero point 0.1 or 0.05. And so we would go that amount on either side of 7.6. So between 7.55 and 7.65 centimeters. Now that decimal value is greater than 1 and every digit is significant. So each of these values, the length has 3 sig figs. And then when we calculate with the area of the circle, of course, we know that that formula is equal to pi r squared. And when we take pi r first being 7.55 squared, we get approximately 179.0 da, 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 and our greatest possible area being pi times 7.65 squared. And we can see we have 183 point, lots of decimals, but we need to talk about taking each of these values, remember, to our 3 sig figs. And so hopefully you can see that that would be between looking at what the rounding kind of wall is there between 179, round to the nearest unit there, and our 183 would actually get bumped up to 180, 4 because of the 8 on the other side of the decimal point. So between 179 and 184 square centimeters. Take a pause on the video and complete this final check here on page 141. Okay, everyone, this is the part of the video where you really want to check back on the answers to those checks that were assigned to you as you were watching. All right, for our check back on page 138 at the top, for example 1, we're asked to determine the number of sig figs in each measurement. Here we have a decimal value less than 1, and so remember we're taking only the digits that are to the right of the first non-zero digit. So hopefully you can agree that that would be the 3, the 9, the 2, and the 7. And so we would have 4 significant figures there. Next, in part B, we have a whole number. So we're only going to count a 0 if it is between non-zero digits. So we are not going to count this final 0 in our count of sig figs. And so we have 1, 2, 3, 4, 5, 6 sig figs. Still on page 138, just at the bottom of the page there, we're finding the possible range for the length of this segment. The measured value looks to be 2.2, and our precision level is 0.1. And so remember, we want to go halfway of 0.1 on either side of that 2.2. Half of 0.1 is, of course, 0.05. And so less 0.05 from 2.2 gets me to 2.15, and we really only have one range in our answer here that works, and so that's choice C. In our check for example 3 on page 139, we are dealing with a mixing bowl that starts with 8.5 fluid ounces, and we are removing 4.25 fluid ounces. So of course this is a subtraction. And so we're going to use the rule for subtraction that a calculation can't have more digits than either of the original numbers. So when we subtract, we get 8.5 minus 4.25 is, of course, also 4.25. But we need to make sure there are only 2 sig figs because 8.5 has only 2 sig figs. So we would actually say 4.3, rounding to that 10th place. In our check for example 4, we're doing a calculation here, which is going to use the measured value of 1,600 tons of snow and take that number of significant figures, which is 2. And so we're going to take our 1,600 tons over 1 hour, and we're going to multiply that by a conversion factor that 1 hour is 60 minutes. And then a second conversion factor of how many pounds are in a ton. Because look at the units we're trying to find. We're trying to figure out how many pounds in a minute. Okay, so pounds should be our leftover unit in the numerator. Minutes should be our leftover unit in the denominator. If we go ahead and cancel out our common units, we can see that that pounds and minutes is in the arrangement we want it to be. So if we go ahead and do that multiplication of 1,600 times 2,000 and then divide that by 60, we get, of course, with that factor of 3 in the denominator, it should come as no shock that we get a repeating decimal value. And to 2 significant figures, we would just keep the 53,000 pounds per minute. And that would be choice C again. In example five's check on page 141, we're looking at an original measurement that appears to be 5.5 inches with a possible error of half of that precision level on either side, which is 1/2 of 0.5, which is 0.25. And so our least value for our radius would be 5.25, and our least value, or excuse me, our greatest value for our radius would be 0.25 on the other side of zero point 0.5, which is 5.75. Each of these values has 3 sig figs, so that's what we're going to want to have in our range of area as well. If we take our least area, that would be calculated from pi times the smaller radius value, 5.25 squared. And on your calculators, remember to find that pi value at the second function of our caret key, as we've talked about before, but that's going to be 86.590. Probably don't need more than that to judge. And then our greatest area is calculated from pi times using that higher value for the radius of 5.75 and squaring that, we get 103.868. Let's see what we're going to get to for 3 sig figs. If we go ahead and take 3 sig figs on our first value here, 86.590, we would stop at 3 sig figs here. And so our 9 would push that up to the next 10th. So our lower measurement is going to be between 86.6, and then our higher measurement, if we come over to 3 sig figs, we would be taking the zero point 0.8 in the 10th place and rounding that up to the next whole unit for 3 sig figs. So that would be between 86.6 and 104 square inches. Okay, we'll see you in the practice.